And clearly I haven't given you the night off because you're managing us all the time already.
All right.
And clearly I haven't given you the night off because you're managing us all the time.
We're live now.
You have to mute that.
I did. All right. Slowly people are gathering. Carl, you can start whenever you want.
Shan, do you need a minute? You have water? Are you good?
Yeah, I have water. I'm good.
All right, we can get started then. And like we said, I think more people will join once we get started too. So let's see. So welcome to our lecture series, hosted by the College of Architecture and Design at Lawrence Technological University. My name is Carl Dobman, and I'm the Dean of the college. We offer a range of design degrees from game design, graphic design, transportation design, industrial design, interiors, architecture, and urban design, a range of scales, a range of design disciplines, and a range of intensities. Everything we do is focused on design, immersed in technology, given that we're at a technological university, and grounded in design practices. And it's so enjoyable when we identify people to come and share their work with us, and that work is relevant to multiple design disciplines and relevant to many different students within our college. And this is true of Shan's lecture tonight. I think it's often very difficult for us as designers to describe something. This thing that we do, it might not yet exist, or the conditions are dynamic, or the concepts might be complex. Sometimes we exaggerate, sometimes we isolate, minimize, or even omit all different types of information so that we can create a description of something. Sometimes the representation might even outlive the item being designed, or the thing that we're talking about never actually comes into being. But representations can be powerful. One example, as I was thinking about Shan's work tonight, was to think maybe old school precursors. And one example might be the Noli Plan of Rome. It was drawn in 1748, but we still talk about this map almost 275 years later, because it clearly articulates an understanding of public and private, and it does it at an urban scale. Amazingly, and apparently, Rome was still using this map for planning purposes into the 1970s. Its extended use was probably due to the relative static nature of the city. And I'd say this in contrast to the speed of social media today. And I wonder how long representations might persist now, and if that should even be a goal, that representations last for a long time. Data is captured faster and it expires more quickly. I think these are some of the issues that we'll need to consider going forward as designers. And I think these are some of the issues that Shan's work begins to push the boundaries in this area. And so as we were getting started and I was thinking about introducing Shan, first I had to do the thing and realize that Shan and I have known each other for at least a decade, maybe 12 years. And I was doing that math this afternoon. But to introduce Shan, after completing her bachelor in architecture in China, and I think in 2008, she said she moved to Michigan. She earned a master's of architecture at the University of Michigan. And working with her there, I can attest to the fact that she could design, she could digitally model, she was starting scripting, and she also had an incredible design sensibility. She moved from Michigan to Boston and she worked at Blue Homes, where she helped to build an online design configurator. This allowed people to design their own home in 3D based on pre-made design decisions. From this experience, she enrolled at MIT because I think for Shen, having one master's degree just wasn't enough. And so she left Blue and went to MIT, and she did a master's in design and computation. While there, she worked at the MIT Sensible City Lab. From there, she went on to Uber, and she was the founding member of Uber's data visualization team and creator of Kpler.gl, an open source geospatial visualization tool. This tool was the gold winner of the Kantar Information is Beautiful Award and nominated for the Breakthrough of the Year in JavaScript Open Source Awards in 2018. I followed and I have followed Shan's work, and I was really excited by the way that she was capturing urban data, making it tangible, making it legible, and making it vivid. And if that wasn't an incredibly cool job, she left Uber and she co-founded Unfolded. And there, in addition to being a co-founder, she's also the chief product officer. She's here tonight to help us expand maybe our understanding of what role architects and designers might play in the future, what role data might play with this. She describes herself as a coder, a designer, and a data artist. I wish she could be with us in person and so that we could catch up more tonight, but it's my pleasure to introduce Shan He, welcome her virtually to the college, and let her share her work with us tonight. So welcome, Shan. It's great to have you here, at least virtually with us tonight. Welcome.
Thank you, Carl. Yeah, it's an honor to actually be invited to giving a lecture at the architecture school because of my background in architecture. When I was giving talks to software engineers and data scientists, I don't feel as nostalgic at it as it is to giving talk to architecture because my past from architecture to computer science to data visualization has captured all my desire for being a good designer and being a good technologist. So with no further ado, I want to introduce the topic I'm giving tonight, from digits to pixels, because as many of you guys might know, my work is focusing on data visualization, specifically in visualizing the geospatial data to understand the urban informatics, to understand how people use the urban space. So, today in my talk, I'm gonna talk a little bit about data visualization and, the practice of visualizing data and the practice of visualizing urban data in one of my tools. So Carl already talked about my background, so I'm gonna just go very quickly. Yes, I studied architecture. I got 2 masters, and I work as a software engineer, as founding members of Uber's visualization team, and I built a open source software as I was there, and now I co-founded a company called Unfolded. I call myself, data artist, coder, and architect at large, just because deep in my heart, from the very early days of my career, I am an architect, I'm still one. So, many of my practice is always focusing on using good design and advanced technology to solve problems that people have with data. So what is data visualization? This is a question I got asked all the time. In one word, what do you do? I would like to say data visualization comes in many different forms. The most common one you guys see every day is probably, colorful pie charts like this. Or many graphic designers will know visualization as infographic. We use, symbols and colors to find a different way to represent information. Or as many of data visualization practitioners know of visualization, It's more of animation, using colors, using different scripting techniques to tell animated story about data. I would say all of that above is visualization, and it's my day-to-day work, and it's all encapsulated in the concept of how do we better use infographic, use animations, use basic design skills to make information or specifically make data easy to understand. I would say data visualization lies in the conjunction of 3 skill sets: design, coding, and storytelling. All of 3 skills are extremely important for a data visualization practitioner because we want to be able to reveal patterns of data. We want to make data easy to consumption, and then we want to turn data into actionable insights. And we want to tell a better story of data with our skills. So as an example of explain to you what is data visualization, I want to tell a little story of how do I go from architecture to data visualization. Carl already gave the verbal description, but now let me to introduce you using my own skill sets. So, when I was telling a story about this timeline, I like to draw diagrams. I started from University of Michigan, study architecture. There, I learned skill sets such as graphics, illustration, urban studies. I take Carl's parametric design courses to learn scripting, and I gained these little bit experiences as in architecture school. And after graduating from Michigan, I started working at Blue Homes, where I started to build this, 3D home configuration tool. From there, I learned a little bit about, UI, UX design as a web developer. I learned just basic web development, not crazy. I still don't know the foundation of software engineering at that moment, which takes me to another level. I realized just being a designer, I don't get to build things that I design. And as if you're a controlled person as I am, I like to be able to actually build things that I design myself. That takes me to go back to school, taking another master's at MIT. I studied design computation, where I take fundamental courses of software engineering. I learn data processing, I learn web frameworks, and then I learn GIS softwares to better equip me to do both data processing and visualizing it. And all of the above takes me to Uber, where I become a visualization engineer. I work in conjunction of design and software engineering. Now, this is the boringest diagram you can draw, telling a life story about someone. And as a software engineer, this is the way I like to tell information because it's clean, it's clear, it's structured. But as a designer, I hope you guys don't take pity on me. This is definitely not the things I would like to show people. So to show people the life story of me turning from architecture to data visualization, I actually built this visualization myself. Using these bubbles as a representation of skills that I learned through the path of my career, how I gain different skill sets at the different places, how I take those skill sets to my next chapter, and then how I take all the skill sets I gained, computer science, design, graphics, data processing, urban informatics, into my position as a data visual engineer at Uber. The 2 things I just showed you are 2 fundamentally different ways of telling stories about someone's career path. They're both valid and they both have their own merits, right? One way is extremely clear and clean, boring, I would say. The other side is graphic, vivid, as interesting, and it gains your attention. So, both of the ways are valid to me, at least, to tell a story about data is really in terms of what your audience and what you want to convey. But I would say that as a visualization engineer, I would prefer the second way to tell my stories. And this takes me to tell you what is the most important part of visualization. That is the power of seeing. Our human eyes are not built to understand digits. They are not built to understand graphics like this. Every single digit means a something, but to our eye, it doesn't mean anything. If I show you this just pages of 0 and 1s, it's impossible for you to understand what's actually behind it. That's why we're taking graphics to this game. Once I turn these numbers and digits into colors, and I actually just give a simple color code from 0 to 100 or from 0 to 500, yellow to blue, the pattern of it has become immediately visible. Now, I would like to say this example is a little cheesy, but it gives you the importance behind why we need visualization to understand data. And another reason why we need visualization is because numbers are very cold. When I say the sentence of there are 125 million buildings in the United States, yes, it's a statement. It doesn't really become very tangible to you. But when I show this graphic, actually showing you where there's 125 million buildings are, this statement become extremely powerful. Now, it might not be exact, because I can show you a map of 100 million or 50 million. They might look exactly the same, but just the power of turning a number into a graphics becomes something that the most powerful skill set of a data visualization practitioner, because they turn the data into something that close to you, close to your heart, because you live in the space. You are immediately trying to find okay, where's my home is it on this map? That information, 125 million buildings, becomes something that much easier for you to remember or to understand. So, okay, let's talk about maps, because a lot of my work is not just about visualizing data, but specifically geospatial data. I have my background in urban studies, and I'm an architect at heart. So understand the physical space through visualization design has always been my passion. Maps to me is a graphic representation of the physical space. There are many elements that's important to designing good maps, and I can go on for long, but for the sake of time, 2 very basic attributes: scale, projection, and symbol. When we turn map into something that actually embed rich data, we use symbols to better assist us in terms of designing data-driven maps. There's our basic symbols we use, like points, shapes, colors, orientation. Those are basic graphic attributes that we always use in any type of data-driven maps. This is a very early maps, data-driven maps. John Snow, not that John Snow you guys know of, but the Dr. John Snow, who is a British physician in 18th century. He drew this map during the big cholera outbreak in London. He drew this map to show where in different households how many people are died. So he uses black bars to represent stack of death. And just by drawing this map, he was able to trace the outbreak of the virus actually concentrated just around this intersection on Broad Street. And then he was able to trace the source of this outbreak is because there's one water pump that was polluted with cholera virus. So this is a very good example of how a simple symbol can be embedded in with data that help us gain insights into where the outbreak of a virus is. Another symbol we always use in data-driven maps are dots. So dots are uni-shaped, and when you have through a lot of dots on map, we can use the color of dots to show different patterns. So this is a map we call dot density map, that's showing the ethnic group of 2 different American cities. One is San Francisco, one is New York. The one on the left is San Francisco, where the red colors are, where the white people or white ethnic groups are, and the blues are Black. And between yellow and green, there's, I think, a Hispanic and Asian population. So just using this type of colors represent percentage of ethnic group, we can immediately see the patterns of different ethnic group are residing into the cities, and then, then draw the conclusion about segregation, about different neighborhood development in terms of different ethnic groups. So this is a very common way of showing, densities and showing categorical densities in terms of data-driven map design. And this is another popular maps we always do. We call it chloropleth. So instead of using unified shapes such as dot and bars, a chloropleth using the actual geometric boundary of the of geographic location. In this case, the polygons are showing the actual counties of US, and red and blue are showing the percentage votes in terms of Republican or demographic votes. Now, chloropleth is a very straightforward way of showing the actual geographic boundary in terms of political boundaries. But it's actually not the best way to when you are comparing quantitative information such as number of votes. That's just because the shape itself is only relevant to geographic area. It has nothing to do with the actual density of population. In this case, where all the people voted in the red area equals the number of people voted in the rest of the country. That's just to say that, using something like a chloropleth, it's good to show categorical value, but not so scientific to show the numbers or qualitative numbers between two different type of voters. And that gets us to improvement on chloropleth called cadograms. So cadograms are type of maps where the relative geolocations of area are preserved, but the shape itself are distorted to embed a third level of information. For example, in this different type of cadograms we draw, we are trying to distort the area of each state just to have the shape relatively closer to number of votes or number of population of that state. Drawing something like this will help us our eye have a more straight relationship with the numbers or the density of population rather than the areas of the state. But again, cadogram is extremely hard to do. It's not as straightforward as a chloropleth, so you don't see that many cadograms being shown used as a result of election. So the final graphic elements we do with maps is turning them into 3D. Through the recent technical development, drawing maps in 3D, animating them has become possible and more easy to do. In this map, made by Nicholas, who was my manager, he used this 3D type of maps where the points are showing the wind, the particles of points are showing where the airflow is, and then the angles of the triangles are showing where the wind direction is. So using the basic elements as triangle and dots, but adding movement to it, this help us much better understand how wind is blowing in the entire US continent. Now, I just quickly go through different ways we design maps. And from maps, there's actually more to talk about when it goes to geospatial visualization. Now, the normal maps we see, all of these are maps. From left to right, we go from the most physical space to the most human activity. So on the left side, we see coastal lines, we see beaches, we see ocean currents. On the middle, this is a map showing the Dark Knight project, where the streetlights of New York, Manhattan are reflected through satellite imagery where it has a tangible information, a tangible dimension to show you the population density of Manhattan. The rightmost app is absolutely drawn only by human activity. This is a map released by Strava, showing all the roads ran by their Strava athletes. So when people using Strava apps, they collect the traces where they're where they're running and draw them on this abstract map. So this is not the actual road network of Europe, but it's where the roads being run by the Strava athletes. So all of these maps above are maps, but the ones that we most relevant to spatial visualization are the ones on the rightmost. So when we talk about geospatialization in the area of data-driven urbanism, we are focusing our attention on something called location data. So location data is a new concept that just emerged through the recent decades where the world generated 90% of the data that ever collected over the past 2 years. And over the 90% of the data that's most relevant to urban studies are location data. Location data are mostly relevant to people's movement. When you're walking around, you're taking a personal GPS devices and those signals being collected by satellite and turned into location data. Location data are something about people's movement, something about our traffic. It's most relevant to how human beings reside and using and navigate through the physical world. One of the early visualization I did using the location data collected through Uber's platform, this type of a day in life of Uber visualization. This is a map, animated map, just showing the 1 day of Uber trips happens on the platform. Again, on this map, there's no roads being drawn, there's no streets, there's no buildings. All of it's showing are the actual physical traces moving around the city. And these are all just about location data. So showing you a visualization like this can help you actually understand the power of location data because it's all about our movement and how we navigate through the cityscape. At the visualization team, we make maps to gain insights from location data and to understand how humans reside and navigate the built environment. We have designed many maps and then just using the trips happens on the platform. So this is a map I made using just the start and end of a trip to show how different parts of the city connect to different urban centers. So each of the arcs are showing one trip, but just connecting the start and end of a trip. So this is a map made of the city of London, showing how people travel back and forth from different parts of London. You can see some of the remote centers are train stations and airports, and then different remote urban centers. And this type of map is extremely interesting to urban studies because it gives them the idea how different parts of the city actually connected to each other through people's travel. Another map we did at Unfolded is showing the breakdown using something called hexagonal binning, showing the breakdown of ethnic group throughout the US. So we will be able to take census data. Instead of drawing them as a choropleth map, we project them into hexagons and then using the color of a hexagon to represent the percentage of different ethnic groups. I forgot exactly which one it was, but judging by this map, I think it's the breakdown between the white ethnic group and either the Black or Asian. So I should probably put a label there. And location data is not just collecting through your GPS device; it's also collecting through satellite imageries. This is a map we did at Unfolded. We're using the global human modification satellite imagery that are provided by Google Earth Engine. So through the satellite imagery, we will be able to using a technique looking into the RGB channels of that imagery to understand the level of human modification to the U.S. continent. So from blue to red, the redder it is, the more human modification of the landscape it is. So as you can see, quite a lot of human modification along the Great Lake area, not as much around, the Yellowstone and then the western part of the continent. This is something that I did using one of the tools I designed. Not all maps has to be 2D. This is a 3D map that's showing just the density of taxi trips in New York City. So this is you taking 1 million of taxi trip, projecting them into hexagon bins and adding a height to the hexagon bin to have the density being more extruded in this term. So it's more sensitive to our human eye. Now, all this map I just show you tell you a way of turning location data into visualizations that, showing different type of insights. Now, they all look beautiful in my career. Like, I would like to say that I have made hundreds of this type of maps. When at Uber, one thing I actually really hate when people come to me, one thing I actually really hate when they say is that, they come to me saying, I love your work, they look beautiful. Can I use them as my screensaver? Well, so, as a designer or architect, I actually feel more happy about such statement because design and beauty has always been, part of my design practice. But as the data visualization practitioner, I was really hoping that people can look beyond the beautiful graphics. They can look beyond what is this gorgeous dot map is about. That's just the entrance. That's just like a welcome to my world. But I really want them to understand is the information I was trying to deliver through the map design. And that takes us to talking about the common process that every data visualization practitioner has to go through to create meaningful data. And now, spoiler alert, this process is very painful. So in theory, if you think about my daily job, it will be, I will code most of the time. I will have this fancy terminal running on the background and like seems that things are working. And then I turn my screen, something gorgeous just showing on my laptop, right? So that's the theory, that's the dream. But in reality, it's something more like this. You almost never get it work as first try. You spend most of your day in debugging your code. And when you finally showing something on the screen, it might just be one dot, it might just be a million dot that doesn't like ends. You almost never get anything useful on your first try. So designing meaningful visualization actually requires a lot of trial and error. And us as graphic designers, us as software engineers always know that there is a road to Rome, and it's not an easy way. So we started from drawing sketches. We draw mockups using Photoshop and graphic software, and then we build prototypes, and then eventually we build the final product. So most of the time it got stuck in the first 3 steps, have to go back and forth. And if we're lucky, we got something to work. I will show an example of how this trial and error has taken me from one of my project I was working on. I was, this is my very early task. When I started at Uber, I was given the task of tell a data story about Uber Pool. Now, Uber Pool is a very simple concept. And then the hypothesis is also very straightforward. If there are less cars on the road, it's more efficient. So that's my task. That's what I need to prove using the data and using data visualization. As I go through the whole process, I started by collecting data. I collected 1 day of Uber Pool trips, and then I simulated if those people didn't take Uber Pool, they take separate trip, what will be the traffic looks like? So I immediately started to think that if I want to tell a story about more efficient, about less traffic, I should start by doing something using visual comparison. So I collected all my data. It looks just like that, exactly what you're seeing. Nothing is visible from at this point. So, I started very first try, very simple thing I like to do is just animating it because those are trips, those are passes. If you remember the first visualization I did with London, this is something I would just try it. On one side, I'm drawing Uber Pool trips. On the other side, I'm drawing separate trips. But the visual it's not anything that works to me. So a theory, there's twice as many trips on the left side. But I don't see anything just by looking at it, right? It's nothing is visible at this point. Okay, so I go back to the drawing board. I was thinking maybe, path doesn't necessarily tell. Let me try to use dots. So instead of drawing the raw path, I started just drawing the GPS pings. I tried my second try, I was only using dots. Again, it's quite disappointing. All the things look exactly the same. And then in hindsight, the reason they look exactly the same was because, if you're just using color and opacity, there's only to a certain threshold you will be able to see you will be visually see any difference. If I have 5 dots overlay on top of each other, on the other side you have 100 dots. If the dots are exactly the same shape, you're not going to see any visual difference there. Okay, so that doesn't work either. I go back to the drawing board. I was thinking that, if I want to show comparison of traffic, what will be the better, more efficient technique I can play? So I decided to try to use some colors in here, using color contrasts to show variance. The path is actually quite painful. I have to actually writing a script to calculate traffic volume, just from all those trips happening. I project the traffic volume into different row segments as I was drawing those trips. And then I was able to get a visual like this. Okay, so this has become a lot more encouraging. You can see there are different traffic patterns throughout the city. Certain part of the area has more traffic, certain part has less traffic. So I apply the same technology to my other side. On the left side, I can now immediately see some kind of color variance. There are certain parts of the street has more traffic. If you're taking Uber Pool, less traffic on the other side. Okay, so what can I do next? Because I'm still drawing an entire day of trips. There's still the effect of overlapping happening. So I decided to animating them. The final step I took is that taking the color I have for the trips, I projected them back into each individual trips, and then I started animating them. So this is technique I was using on my first try. By adding colors, this animation has become a lot more informative and a lot more closer to the message, where what I try to say is that you can see there are different traffic volume compared to people taking pool and separate trips. And then, it's very visible now because, I was able to use color to represent traffic volume and then animating the trips according to it. So to sum up, there are many different design methods that goes into creating this visual. I use comparison. I play around with different symbols, and then I try to use color to represent traffic volume. And in the end, I added motion to make the visual more vivid and less cluttered, right? So this is very basic common process of every data visualization practitioner. You started from collecting data, you process them using different software, and you play around with different visual channels, visual encoding methods, play around with symbols, play around with colors, and play around a third dimension. And in the end, you have a set of visualization. You might create many visualizations throughout this process, and it just takes you one step closer to your most desired result. And all of that takes me about like 2 weeks to make this visualization. And when I presented it, I was really happy with this result, but I was immediately tasked another maps like, okay, now can you do this? And I realized that, if I have to repeat these steps one more time, taking another 2 weeks to make yet another visual is too inefficient. On the one side of me as a graphic designer, as an architect, like to go through this design craftsmanship, slowly step by step towards the final design result. The other side of me as a software engineer think that there gotta be a way to make this process less painful and more available to people who don't know all this coding that I know of. So, as data visualization engineer, not just designer, we also build tools to create maps. When people ask me what your day-to-day job like, I would like to say that, I make maps, I make tools to make maps. Sometimes I even make tools to make tools to make maps. That just take me from going back and forth between my designer and software engineer role. And that's why I built this tool called Kpler. So, Kpler GL is a Photoshop-like tool. I like to call it the Photoshop for maps. So it helps you going through this basic process of filtering data, apply different visualization layers, apply different visualization channels to different different metrics such as traffic, volume. It helps you quickly go through your visual exploration ideas and get a close to discover what is inside the data that's worth visualizing. It's a WebGL based, meaning that it works in your browser. There's no backend. It's not a software that only works on Windows. It works on your Chrome in your Safari. It's not ArcGIS, so you don't have to worry about install anything. And just something that I create at the beginning for myself, so I can quickly go through this design practice of trying and error, and then testing what's in the data and whatnot. So we built Kpler for fast visual exploration of millions of geospatial data in the browser. And it comes with the basic visualization types that we always use in terms of visualizing location data. It has a 3D, the 3D aggregation layer. It has this animated trip layer, 3D arcs, and point dots. Almost all the basic visualization types is supported by our tool. And yeah, it's quite easy to use. Usually I just drag and drop a file that has location data in it, and then I play around with different layer types. I assign colors to different fields. In this case, I'm drawing colors based on elevation. I can play around with colors, different colors steps, different width of the of the stroke, and then I can also look at this visualization in 3D, where zoom in and out quickly has make it much easier to explore at a different resolution. And something that we always do is, because almost all location data comes with a time element to it. So be able to animate through time to see how things change has become extremely important for us. So when we build Kpler, we add this time animation function. So if your data has timestamps, it will automatically create a time filter for you, and then you can go through time to see how things are changing. This is a map I did because at one point we're really worried about earthquakes in California. So I one of my colleagues collected 40 years of earthquake, and to animating through it to see when is the next one gonna come. I don't know if we got the result or not, but there are some patterns we can see where at certain years there's a lot more seismic activity going on, where throughout recently there's actually a less activity. And the third part we are very adamant about is we're not just doing points and dots. We're also looking at moving objects, because Uber is all about moving cars, but also because a lot of location data comes with one object moving from point A to point B. So we added this automatic layer where if your called trips, if your data comes in as different rows of moving object, in this case, this is all the planes are flying around in the whole world through I think a window of an hour. You can just drag the data in and it allows to animate through the 1 hour window to see how things are moving. And then, I forgot what point I'm making. Probably the fourth point I'm making here is that we're not just looking at scattered information. We're most of the time wanting to aggregate data into a specific unit and seeing the density of it and seeing a different metric. In this case, I'm looking at the 3D density map of all the trips in LA, and I was able to apply a third dimension, which is the height, to my 3D bins, and using colors and height, I can immediately see where the anomaly is, and then apply anomaly filter to redistributing the density map, so that by just doing this type of exploration, I can just filter out my top tier anomaly and seeing how areas in the normal tier, like a less dense area, are distributed. So all the explorations are extremely important for data scientists or visualization engineer like me, because we want to be able to fast to see how our interaction with the data changes the visual of it, and from there gain more tangible insights from this specific interaction. And not the least, a lot of data comes as origin destination pairs. In this case, I took the commute pattern in England and Wales and draw this 3D arc map showing where people live versus where they work. So this is I think this entire England and Wales. Some people travel quite far to just do their daily commute. Probably not now because of COVID, but this is taking from their census. I think in the early 2000s, you can see some people travel all the way from the tip of the British island all the way to London. Yeah, so just drawing arc is obviously not enough, because we are visualization engineers. We like to make things move. So another interaction I added called brushing is that as we were showing arcs, we can also just move our mouse around this map and highlighting arcs that begin and ends within a certain radius to our mouse. So this helps us just closer examine a specific area in the city to see how people travel to and from this area to other place. And in this case, I was just showing you, here is the, in I think this Midtown Manhattan, and we can see a lot of trips are happening just between Midtown Manhattan to and from the 3 major airports in New York. So this type of exploration is important for people who are trying to understand origin destination travel patterns. Just quickly go through different part of the city to see how they connected to other parts. And third way we do is that not only we're drawing polygons, we're also adding heights to polygons. A normal chloroplast now become almost like a 3D Lego map. In this case, the polygons I'm drawing are the the building footprints of San Francisco. I added height to have it directly correlate to the height of the building. I also added colors to have the color correlate with the altitude of that area. So as you can see in the center part, Nob Hill is where the tallest part of San Francisco is, and then how the different part of the city where almost all the high-rise buildings are in the lower altitude area, and not that many high-rise in the higher part. Okay, so yeah, almost toward the end of presentation. Obviously, as a engineer, when you build a software, you want to open source it, meaning you want other people to also be able to use the software and then contribute to it. So That's why I was at Uber, I open source Kpler. It is hosted on Kpler.gl. It's like a very simple application that's browser based. So meaning that there's no backend. You can just go to Kpler.gl/demo and start to play around with the maps and in your browser. And I have seen many interesting usage of Kpler.gl, and people actually tweet about it. I have seen an architect using Kpler.gl to draw this cadastre in Venetian of 1800s and see how different building drawings are being extruded into 3D. That was quite interesting. So it makes me feel like very happy, because as a designer, as a software engineer, I want my tool to be able to use by non-designer or non-software engineer, right? So people as geologists or people as architects can use, or environmental study scholars can use that tool to also understand spatial data without writing a single line of code. So that's all of my presentation, and my current job is at Unfolded. Unfolded, I took Kpler.gl, I built on top of it. It's I want to build a platform so geospatial visualization become universal, become a cross-platform for people with different backgrounds. Graphic designers, as data scientists can all use this tool to play around data and get insights from it. Okay, so that's it. Yeah, I would like to take questions if you have any.
Thank you. That was amazing. I'll tell you also that my trick was to have it, I was also watching YouTube, which was delayed slightly. So I got to see some of your maps for a little bit longer because they're gorgeous. And you were going so quickly, I got to see them a little bit for just a few seconds longer, which was nice. Some of them I just want to crawl into and I don't know, roll around in them. They're amazing. Yeah, let's take some questions. We'll see. Sometimes it takes a second. Takes a second for Philip to unmute. Here comes Steve.
On the map, I was fascinated with the map where you were showing, where you turned the patterns of the cars. I think it was the Uber, comparing the two different Uber systems into colorization. And the movement, was that based on the speed of the trips as well?
So it's not based on speed, but it's indirectly based on speed. Basically, because you are driving in a very slow speed, and then I was taking a 5-minute snapshot of every road segment. If you draw at a very slow speed, you will have more cars just in that road segment for that segment. So it's I was able to turn that kind of segment number volume for cars there into a color. So but the actual movement of it is based on speed. So this actual movement in here is showing the speed. The color show is reflected of the traffic volume.
Shan, thank you. Really, it was a fantastic presentation. I want to push you just a little bit. When you showed the sequence of exploration into the representation of the agenda of Uber to show that the ride sharing was better than single use, it talks about a type of agency that's social political. What's yours? You have an intention?
Oh, disclaimer, I'm no longer at Uber anymore.
I know you're not at Uber, which is why I'm asking you. Because when you make these things, right, you understand that when we put any object into the environment, we have a social political agency with it, and then we let it go. And so these are ways of us to engage in a type of discourse. And I want to just pick and maybe a little bit deeper and see if you have, say, a larger agenda on top of the data visualization.
you know, for me as myself, I would try to be most truthful. You know, like I will take the data, I do not skew it. If my data doesn't show me any relevant information, I will not fake it. So when I started at this task, you know, the first, actually the most important part is to setting the hypothesis straight. In this case, you know, I do not just say that, okay, let's take random days, one day compared to another day, or let's just take, you know, random data. This is fastest data compared to Uber data. It's not relevant. And when you work with data, what we want to say is that you want to tweak the variables very, very minimal. So you focusing on the comparison itself, which in my case is like, okay, you know, there are a valid hypotheses if to say, you know, part of it Uber pool, on the other side, no Uber pool, and what will be like. And obviously we do not have the data to actually make the relevant two scenario become in the real world. Then it's all becomes, okay, if I make this hypothesis, whether I can, you know, show it in a scientific way. So myself, no agenda whatsoever, obviously, but also, you know, as a visualization, there's so many people are faking their data, or there's so many people just tweak the color a little bit to accentuate some message. In this case, you know, throughout my design, I show you truthfully every single step I take, even the color scale, how I just do linear, you know, there's no square of different classes there to show, okay, this is the actual result. You know, obviously once I be very transparent of my process, then people can do their own judgment of whether it is scientific or not. It's better than just me showing the final result saying, hey, you know, this is better, right? It's like I'm me showing you, here are the step I take and here are the result I arrived at. And then, you know, anyone can take this and to see whether they agree with me or not.
I mean, this case in particular is one where there's almost like a revenue versus an environmental outcome, right? Less cars on the road, but it also is more efficient and less emissions as a result of it. And so I think you could start to understand what the implications of some of this analysis might be.
Yeah, I mean, there's obviously other things we can try to measure as well. If you really want to go, you know, try to measure the emissions, and then we can make another one, say just to use the data we collected via emission, whether we can make more, you know, study there. So I think there's a different venue there. And at the early stage, when I joined Uber, I think this is the first month or two when I launched this platform, you know, and then I got the data. I was just trying to see whether there's anything I can take out of it.
I have a question. So Shan, thanks so much for your talk. I really enjoyed it. I also really like data visualization, and so I'm like especially excited about your talk. I was really interested in the way that maybe like an overarching theme through your talk was the tension between beauty and information, or, you know, beauty and data. And so I was like appreciating the moment when you said you get really frustrated when people want to use your maps as screensavers, that their beauty almost sort of overrides their meaning or the information embedded within them. And so I was sort of thinking about this kind of tension between beauty and truth, maybe beauty and information throughout your talk. I don't know if that's, you know, I don't know if that's a fair claim to make, and I'm interested to hear, you know, what you say about it. But I was wondering, and maybe this is kind of also building off of Philip's question. I was following all the moments when you were talking about how value judgments get embedded in the images that you make. And, you know, I'm specifically thinking about right now the series of maps that you made of the of kind of like electoral politics in the United States, right? And all these different ways to see how people are voting and what people's political affiliations are. And I was wondering if for you personally in your career, if you could think of a moment when you had to make a really difficult value judgment about how to represent data that you're processing, and just how you navigated that process. So, maybe this is also a different way of asking Philip's question. What are the kind of values that you hold as a designer that guide how you make decisions about these kind of really, really fuzzy, sticky kind of questions?
Yeah, it's a interesting question, but I would try my best to answer it. So I would say, sometimes in the work of data, almost there is a rule of thumb: is the ugliest the graph is, the better, because if you just show them ugly graph, you actually people are even just, okay, that's real data. But if you show them anything with like beautiful colors behind it, they think you're trying to overshadow the meaning behind it. So even to this day, I'm still battling. I'm not saying that I solve it myself. I'm still battling between, if I show you something like eye candy, I got that word a lot. Will you take me seriously in terms of the message I try to deliver, or you just think that I want to show you something, get your attention, and you move on with your life? To me, I try to take the approach where if I take the approach where almost like I want to show this. This is always my starting point. No matter what I do, this is my starting point. I will make the storytelling scientific. I will make the information straightforward. And then I go into, make them pretty or animating, to get your attention on it. I don't starting from it. I think some people might starting from actually drawing this, and then because they want to make the visual more vivid. But to me, I think the actual data, or it's the information itself, it's definitely the top priority. If my visual cannot convey this information, we as designer has a better judgment of whether you're overshadowing information with pretty things, then that, to me, like, that's a no-go. So if I don't know, if anything, maybe this visual I was playing around with. This my co-founder Sina, he made this. I think when he was initial version of this, he was using 2 color tone on this, some density there. It's become very flashy. You almost have this disco light type of result. But I was trying to tell him behind, if you just want to show density, use 1 tone. Do not use more colors there. It might look flashy, but it's not the straightforward way to show density. So there are design principles we apply to make the information more valid versus the visuals more, more attractive.
I also wonder if there's an aspect, there's the complexity or the amount of data that you're working with too. And I think if you can't measure something, you can't really work on it. And one thing that I picked up on that you said is like playing with the data. And at a certain point, I don't think you can play with something unless you can, I don't know, thinking about it with my hands, unless it's tangible, you can't play with something. And unless you can't wrangle that data, you can't play with it. And so I love this notion that you created a tool to allow people to be able to play with the data. So in some ways, and maybe this is circumventing a couple of the questions here, and that you made a tool to allow people to be able to play with the data, right? And if you can visualize it, it's tangible. If you can manipulate it, it becomes tangible. And then it's up to someone else to maybe have an agenda with those things, right? So I think as a tool maker, there's an aspect of you just bringing a capability to someone, right? But I think there's also, back to Emily and Philip's question, is it could be good, it could be used for good, and it could be used for evil. And I think you're but at least they're using data, right? As opposed to something else, maybe.
Yeah, I mean, there's so many ways to be evil in this world right now. So I try not to be the one that's right on the frontier. Yeah, I guess, so there's always, I guess, you kind of also fall back to when I first started my career at Uber, I make things like, this animation moving around, and I make visuals like the Uber pool that, started to tell how take a hypothesis, turn into a visual and tell a story of it. And then as I go down my career, I feel like, if I just doing this day by day, I can be pretty happy at Uber. But then, what my goal as a like promoting methodology instead of just being the map maker is that, I can take this methodology and build that into tools. So, you guys can tell me whether this makes sense, or I can make people equip them with something that I believe are a valid methodology in looking into data, right? I will give them the different color scale they can use, but also I would say that, you can only use quantitative color scales with quantitative data. You cannot use, linear scale in this case. So I will actually, building all the theories into my tools. So, in a certain way, I kind of promoting a more scientific way of exploring with it. I'm not like saying I'm a sense, but just taking what I know of and having through this way of designing tool to, better promoting my toolmaker rule. It's something that has become my rule, I think.
Well, that's a really beautiful way to say it too, because I think we often feel like it's a binary oppositional condition, right? It can either be scientific or it can be beautiful, right? Or it can only have methodology, or it could be pretty, right? And I think what you're doing is but your tool brings those two things together, right? You embed the methodology within it, but it also produces something that's incredibly evocative and vivid, which I think we've all been subjected to far too much data and not enough kind of visualization or thought put into some of those things. So I think it's a really, I don't know, we probably struggle with these things on a number of levels, right? The technical versus the aesthetic. And I think to be able to bring those two things together is incredible. I think it's also like, to me, it's hard to fathom the amount of data that's behind something, right? That you're not drawing the street, you're only just tracking a car and where it's passing through the city. And we can start to, the dynamism of the city is something that emerges from the data as opposed to an a priori notion that like, this is what the city looks like. I think it's a way that we can start to reimagine things in a different way.
Mm-hmm. Yeah, totally. I think, the interesting part is I have two rules and they're both very yelling at me. One is like making beautiful visuals, you're a designer. The other is that you're a self-engineer. This has to make sense, has logic in it. And that it's like battling even in between those two selves has been very interesting even to the day, right? Every day I will write code and will look at my screen saying that, yeah, this doesn't look good. And then I'll go back to change the code. Or I will look pretty on the screen and I will complain that this code, man, just bad. Built up by hangers and duct tape. We should make it like more efficient. So,
do you think it's necessary to get 2 master's degrees so that you can have an angel on one shoulder and a devil on your other shoulder?
I don't know. I think every designer is probably a devil and an angel at the same time. So you don't really need 2 masters to do it. Yeah.
But I think it's clear that brings a different methodology and tool set and approach to your work, which is really incredible.
Yeah, one thing I find is interesting is that, so my early career at Uber, I joined as a data visualization engineer, right? So when I talk to designers, they immediately think that I'm not as good at design as they are. And when I go talk to engineers, they immediately think that I'm not as good at engineer as they are. So, I think it's the same story to every single data visualization person, just because you wear 2 hats, you were put in this condition where, people who only know one thing think that you're not as good as they are in that specific domain. And I think it takes me a very long time to, maybe it's also because I go into this tool making because, I demonstrate enough I can do good design, but now let me demonstrate I can also build, good software.
Well, and maybe that's a great way to put it too, because you're become a really excellent role model for some of our students who will be operating in industry where there's not those clear distinctions. And I think what's clear from you is maybe you're brave enough to talk to engineers as a designer, and you're brave enough to talk to designers as an engineer, or vice versa. I think maybe I got that wrong, but I think it also, you point to the fact that there is a kind of, I don't know, emerging disciplines between fields, and we're certainly having conversations at the university level about what are the next degrees, right? What are the next careers to be in? And I think you're operating in a space that's clearly between two different places, and then maybe that starts to infill with someone that is that this becomes a discipline rather than being a discipline caught between two. You're laying the groundwork to start to become its own discipline. I think these are things that are changing.
Yeah, I think not many schools even today has like a specific degree for data visualization. I think there are a couple of masters that WashU has a master or PhD program for visualization, but they also always start after undergrad. So you might not take enough courses to immediately go into the visualization masters. You might have to take more courses because you need to take computer science, and then you need to take graphic design. So all of that are important courses you need to take before you actually take the statistic as well. So it's quite diversity of things.
So speaking of crossing disciplines, as I'm looking at your work and hearing this conversation, I apologize for all the transportation noise here. Maybe you can track it, put it embedded in a map. But I'm thinking of John Cage and the work that he did to transliterate movement and objects and space to another discipline, which was, I'll put air quotes around it, music. Have you been approached by, or have you approached another discipline like theater or musicians like David Byrne from the Talking Heads or Brian Eno? Two that come to mind. Have you considered that?
When I was making this visuals, I was actually using some kind of, there was like actually background music behind it. So as I was building visualization like this, I thought this could be a good kind of animation or theoretical cinematic piece where you play around with transition, play around with lighting, adding music background behind it. So I did play around with After Effects when I was doing some of our visualizations to choreograph it together. And then it is I will say another level of storytelling. It's not just static visuals. You actually be able to compose a piece that deliver information that's even like matching your visual movement with that specific tonation in the sound. It's interesting part. Yeah.
Thank you.
All right. Well, I'm not seeing any questions on YouTube, and unless there's any questions from this group, I want to thank you so much for joining us tonight. I think there's the other conversations that happen in the background. So between us texting one another about this class needs to see your lecture and this group needs to be aware of your lecture, and oh my gosh, so and so is just talking about something. I think that you give us a lot to think about both tonight, and I think your lecture is going to be watched by many more people in the coming days as we start to share.
Okay.
Why weren't you here tonight? You should have seen this. And so I want to thank you for taking the time to share your work with us. And I don't know, I imagine there may be subsequent conversations that come from this too, given the way that we've been talking about design and technology within the college. I think you're a really incredible role model for our students, and the work is really beautiful. And I don't mean that as an insult. The work is really beautiful.
Yeah.
So thank you.
Yeah, I still take that as a compliment. Don't worry about it.
So thank you so much. It's nice to see you. Hopefully, there's a moment where people can travel again and we can get you out here, and it would also be nice to come and visit you out there.
I would like to visit Michigan again. I haven't been back for so many years. So it's a good time. It's a good season to be in Michigan as well.
Yes.
This
right.
fall. Yeah, thank you so much. You know, it was great joy, fun to talk through things that I did, you know, 4 or 5 years ago. It's yeah, also helped me a little bit to reflect on my steps.
It was great. Thank you so much. And
Yep,
thank you for everybody joining tonight. And I look forward to continuing these conversations with our next lecture series. All right.
Great.
Good night.
Bye, guys.
Good night.
Thanks, Shan.